Hey guys, welcome back to another dev blog. This is the third one. I think they've been going really well. If you guys have been enjoying them, then please let me know down in the comments. If you have any questions about stuff I'm talking about, then again, let me know. So a couple of things to talk about today. Sorry we missed last week. It's been a bit of a jam-packed couple of weeks. So first up is BridgeOS. How's that going? The answer is really well. I'm actually really happy with the progress that I've been able to make on some of the restructuring and refactoring of BridgeOS. It was a bit of a stumbling block with rewriting the EEPROM drivers that handle the non-volatile memory storage. So, your preset management, your global config for the device, all that sort of stuff. And there were a bunch of changes that I wanted to make, which were really beneficial for both performance, also for like loading times, in between presets, boot times, optimization speed when doing like a factory reset, stuff like that. So yeah, hit just a couple of unexpected hurdles, but that's all sorted now and it's going really well. So ported over to the new IDE, done a lot of restructuring and refactoring into that, and BridgeOS is up and running in sort of all its basic functionality. You can navigate your banks, foot switches do their foot switch things as you would expect. That's all going really well. So what I've been working on for about the last week and a bit is completely overhauling the device API drivers, so how the device communicates to the editor or other applications people might want to write. Yeah, that's probably been the biggest challenge. So like I've mentioned before, we're looking at porting that from serial, so more specifically web serial when you're talking about the editor, over to sysx. I mentioned why, but a quick recap is one, for robustness, and two is for like interoperability between different browsers and things like that. For example, on a mobile device, it's a lot easier to use a MIDI device in a browser-based application than it is a web serial device. So it'll allow us to open up the editor into sort of more mobile applications, tablets and things like that, which is really cool. So as well as, just sort of speed, robustness and reliability, like I mentioned. So that's kind of moving that. And then I'm also sort of restructuring all of the packet passing. So it uses a JSON protocol, completely restructuring the handling of that to make it more performant. So that means faster uploads and downloads to and from the editor, and also some of the weird pesky errors that might pop up when you're transferring a profile to your device. Yeah, along with that has been sort of adding underlying deep integration for sysx, system exclusive messages, which will make their way into the foot switch stacks and things like that. But yeah, really happy with how that's going. I should have something to show you. I mean, it's going to be a bit of a boring preview, I guess, because it's going to be like, hey, look, it does the same thing, but better for me to manage, I guess. And then we'll be introducing some of those new features in upcoming firmware updates as well. One thing to mention, I know this probably isn't a big deal to most people, especially now the editor's been live for quite some time. I did remove a couple of the menu functions. So the onboard, create a template, copy from one foot switch to another, things like that you do on board in the device menu, which were really there before the editor came out as a way for people to easily, copy and paste their blocks of functions, which now with the editor really isn't being used by many people at all. That kind of collection of things was, I guess, very finely tuned and finely written terms of the memory allocation and how that was being handled by the OS, and it just simplified a lot of things, getting rid of those, for a feature that really isn't required anymore. Now the editor has all of that functionality and more. If you are electronically minded, something you might be interested in is a bit of an investigation into why sometimes your device might take a couple of goes to enter into the device firmware update mode over USB. Sometimes it doesn't go straight away. You have to try it again. Really weird bug, not really a bug, but really weird reason behind that. And I kind of got to the bottom of it. So you'll notice that we recommend connecting your flexi ports with a TRS or a TS cable. I think actually a TS cable is the more robust way to go. But the reason being that a microcontroller, so this is a blank Bridge 6 board, so a microcontroller like we're using on here, will have multiple ways of updating the firmware onto it. It could be USB, it could be over an SPI or an R2C or a UART port. So we actually use UART ports on the flexi ports. That's the underlying hardware standard for MIDI, a UART port. It's very sort of basic serial communication protocol. And one of the UART ports that is specified as being able to flash the firmware is actually being used for those flexi ports, so not a problem. And I was really wondering why on a couple of demo boards I wasn't seeing this issue at all, but then, we'd get maybe a customer's board and I could see, okay, this is taking a couple of times to update the firmware. And also why I never caught it in the first development cycle is that when nothing's plugged into a flexi port, as these here, it's fine because the traces running to the flexi port are very small, they're very low parasitics. But when you have this TRS jack here, you've got this big metal connector, which is essentially floating. It's not connected to anything electrically, and that's probably a design oversight on my part. But what's happening there is because it's now got this big long metal, essentially an high impedance antenna on the RX pin, that you might be just picking up spurious noise floating, thereabouts or bits and pieces, and can kind of cause that pin to maybe float, and it's picking up a spurious signal on there, like a fake signal, which is overriding the USB mode. Now, long way to say that this can be really easily fixed in future hardware versions by tying that pin to ground via a resistor when not in use. So very easy sort of fix, but it doesn't affect the functionality of the device in any way apart from the utility update, trying a couple of times for the firmware update. But thought you might find that interesting. Sorry, I'll try and stop moving around so much. Another thing I wanted to touch base on is a topic which is, maybe even more niche than the last one, but it's, should you buy a pick and place machine? That had been the discussion I had with myself quite a lot, sort of 18 months ago. And I hadn't talked too much about it up until now, but I thought it might be an interesting conversation to have. You'll notice I'll show you the back of a board. You might be able to see, there. There's these 4 holes in a rectangular orientation. And they are for the angled bracket for the screen to sit into. So there's an angled bracket because the screen sits on an angle like that. It sits into it and then it inserts into the PCB and has a really precise alignment. It's all well and good. Now, in the development of our, the Bridge 6, I'd spent, months, if not years, sort of years looking at that hardware design as we iterated, developed and tested. And made so many revisions, spent so long looking at this, and I thought I'd gotten every single duck in a row, so to speak. And this actually ties in with on the original batch where we had some LED failures and had to, any customer with a failure could send it back and we'd repair it. So I had the PCB design ready to go. The board was all good. Sent it away to the contract manufacturer, the place which will manufacture your PCB, assemble all the components on it, and send us the finished PCBs ready to install. And they said, on these little LED footprints, they're actually, we originally used a slightly larger LED, but they said, could you just make the pads a little bit bigger underneath? And I thought, sure, best for sort of automated assembly, and so I did. And like I said, I must have had dozens of different board iterations made. I looked at it so many times, and they all came out really well. And just this last stumbling block where we put a very large order on the way and gave them a lot of money from our Kickstarter campaign, just for whatever reason I didn't check that change might not have pushed some traces out of the way and caused some issues. Now normally they'll check for this, but for whatever reason it also went by them because they checked everything in their first design for manufacture check. And it's kind of staggering because that was probably the most money I'd ever spent in a single purchase on getting PCBs made and assembled, and the fact that I didn't catch that was staggering. But it's just one of those things where you can do something right 999 times, and on that 1000th try you muck it up. So anyway, when we got them back, we actually had to desolder some of the LEDs, cut a trace underneath, put some high temperature capped on polyamide tape underneath to stop the LED from shorting, and then resolder it. And just either in travel or we missed a little spot on part of that repair we had. I think about 5% we had to get back and then fix up and send back out. So that was mistake number 1. And mistake number 2, and I promise I'm getting to the should you buy a pick and place conversation, is the screen bracket. Again, in this last change, for whatever reason, I didn't the component that is the holes for that screen bracket weren't included on the board. So we got these assembled boards back, tens of thousands of dollars worth of hardware, and it didn't have this mounting for them. And I was like, crap, what do we do? We've got 300 boards that we can't mount our injection molded, also very expensive, display adapters to. what do we do? And in the end, I thought maybe I could make a jig and an alignment and drill the holes in, but I thought, oh, that's risky, to say the least. Very, very messy, very risky process. Anyway, we created a system where on our laser cutter, created some brackets that fit the enclosure, pretty much perfectly. And we used some high temperature, high industrial strength adhesive to sort of fix the screen to the display so it would be aligned perfectly, and then the ribbon cable would attach to the board. Long story short, mistakes were made that were mine, and it was a really good learning experience. And obviously we got there in the end. It really sucked, and I really felt for someone who got their hardware after waiting so long for it, and it had this issue. I like to think that we took care of it. We paid for the return shipping costs, we paid for the cost back to them, we fixed it up free of charge. But it still really sucked. It was really unfortunate. But I learned a lot from that. I guess I came away from that experience with just this fear of like, it's such a big thing to commit to, and you've got so many things to check, and one thing can bring you unstuck. And so I thought, well, if we assemble them ourselves in-house, maybe we skip all of that. I knew a reasonable amount about, or I thought I did, about the assembly process with a pick and place machine, which, if you don't know, is a machine. It's got a big head and it comes along and picks all the components and automatically puts them on your board. It's got cameras to see where everything is, and a conveyor, and then it goes into an oven to sort of reflow the solder, and out comes a finished board. Oh boy, if you are thinking about getting your own pick and place machine for small to medium scale manufacturing, think very carefully. So we've had out our line for about 18 months now, and as of 2 weeks ago, I'm finally feeling like I can do runs of, a couple of hundred boards or something like that in one go and be really confident of the results coming out. I've learned a lot. But yeah, do not enter into that lightly. It is a process. I'm feeling really confident now with where we are in our manufacturing. We're going to be ramping up our production and, sort of getting rid of any pre-order, any wait time, which is really exciting, but it has been a process and a journey. If you're interested more about that, let me know. I'd love to chat more about that. I know it's not everyone's cup of tea, but alas. Moving on, if you've made it to this far in the video, congratulations, you are a hardcore nerd. But this is a great time to talk about something that I sort of previewed in our last episode and then posted a bit about on our social channels. This board here. Say hello to PicoMod. Now, this has been something I've been working on a bit in the background, just, an hour or two sort of at night after my child's, in bed, or I just need to change change up what I'm doing, something like that. But it's just been sort of chipping away, and it's an idea I had a while ago where I've got a whole bunch of pedals that I would really like to control with my bridge. But they're non-MIDI pedals. So I thought, well, I'd love to create a tiny little board that was a bit of a general purpose board, but had everything I need on it to be able to, modify to give a non-MIDI pedal, MIDI controlled bypassing, maybe some extra pins for controlling, emulating an expression pedal over MIDI, that sort of stuff. And so we landed on this. Now, this is the first prototype. I've got some more boards coming that have some minor tweaks, but the only it's essentially the same. And this board is tiny, finger for scale, glass guitar slide for scale. It's very, very small, very sort of, pretty intense board in terms of the routing and layout. This is really cool, and this is going to be an open product in terms of hardware design. The plan is to make the PCB and schematic files for this available for anyone to look at and to use, but we're also planning on selling these for both just sort of individual modders or people who want to make some small batch pedals and have kind of full MIDI control over their bypass, maybe an expression input, all that sort of good stuff. But yeah, it's a really nice little design that I'm going to be showing off a little bit more later down the track. But it's got room for a 1/4-inch connector for your MIDI input, a whole bunch of pins here for connecting to different things like your audio bypass. It's got some expansion pins here for a little expansion board. But yeah, expect to see a bit more of this. We're going to be putting together some guides on how to mod your favorite pedals with this. It's going to be pretty cheap. You can pick some up, follow the guide, even if it's your first electronics project, and wham bam, you've got a MIDI controlled pedal. So very, very cool. It'll have a really nice sort of easy to use editor, so you can play around with things. We'll make the firmware available if you want to spin your own firmware for this. If you're that inclined, you're more than welcome. But yeah, that is obviously not the full story, but we'll be sharing some more details for that more officially over the coming weeks or month. So in summary, BridgeOS coming along really well. Expect some closed alpha or beta releases to be available in the next couple of weeks. Pick and place machines, should you buy one? I don't know. Listen back to find out. PicoMod, it's super cool and tiny. Bridge boards, an overview. Yeah, that's about it. That's all I've got for you this week. If you guys have any questions, as I said, leave them in comments down below. I'd love to answer them if you're curious about any of this stuff, and I will see you all later.